So we're starting by solving. This is just picking up from yesterday's work here. First thing we need to do, remember, is to get the squared part by itself first. So notice that means getting rid of that. So after we add 40 to both sides, then we have something squared equal to, in this case, 49. In order to get rid of the squared, we square root. When we square root, what do we need to remember to include? The plus and the minus. And so make sure that in your work that you included that plus or minus right there. We need to include the plus or minus in front of the number, just the number side. You don't need it in front of both sides. And if you don't remember to include it here, you might be thinking, well, yeah, but I remember to put it in later. That can lead to potential problems. For instance, when we do this and split it up, you'll notice that that means I'm going to end up having to do 7 minus the 5 here, and I'm going to have to do negative 7 minus 5. A lot of people who are like, oh, I'll just put in the plus or minus later, what they end up doing is they end up doing this part of the problem, and then they just say, okay, so I got 2, so the other answer must be negative 2. Obviously, that's not correct, right? Because the plus or minus has to go in when we're taking the square root. Therefore, it's on the negative 7 that we're actually subtracting the 5, so it's actually 2 and negative 12. We're also going to be practicing factoring, and we're actually then going to combine our two skills that we're starting class with a little bit later. So go ahead and factor each of these two quadratics, please. All right, so for that first one, you notice it's just a plain old x squared at the start. First of all, it is a squared, so it's a quadratic. So we know we're going to our quadratic techniques. And it's just a plain old x squared. There's no number in front of the x. So I don't have to use the grouping method or anything extra fancy. I can go straight to what two numbers add to negative 15 and multiply to 36. When you do that, you should come up with negative 12 and negative 3. And so that's it. That's our factored form. Nothing else fancy there that we have to worry about doing. That's good. The second one. If this one was taking you a while to do, you probably weren't thinking of the first step right. Because in this one, you can actually make it really easy if you start by looking to see what you can factor out of every single term at the start. Remember, we always want to look for that first now. And so I look at the 5, 25, and 70, and yeah, they're all divisible by 5, right? So I want to factor a 5 out of every term. When I do that, the resulting quadratic that is left inside the parentheses is now much easier to work with. I do need to actually try to factor this result here, that x squared plus 5x minus 14, but that's a lot easier to factor than trying to go straight away from the first. Not only that, but if you did just factor straight away from the first without pulling out the 5, it won't be right unless you pull out the 5 later. So it's harder, and it's not going to be as right. So you definitely want to pull out that 5 first. And then, so since I now just have a nice simple quadratic on the inside of the parentheses here, it's just a 1 in front of x squared again, so all I have to do is add to the middle number, multiply to the last number. And so it ends up being 7 and negative 2. Notice the 5, it just continues floating out front of it. We're still multiplying the whole thing by 5. After all, these two expressions have to be equivalent. So if I plug something in for x in the first one, I should get the same answer as if I plug something in for x in the last one. They're just different ways of writing them. But by writing them in different forms, we actually can do some work with them. And that's going to be what we're doing today. So we've done all this work with factoring and practice factoring, but you haven't necessarily had a reason to factor. Other than it's really good practice and really builds up your math skills, which, hey, I like that. But there's actually a purpose to it that we can actually use them for. We're going to be solving equations like those today. So notice these two equations that you have here, the left side is exactly the same as the two that we just factored. And in fact, if on your paper you just want to take the work that you did here, where you wrote down that expression, and then just add the equals 0 to it, that would be fine. Because the very first thing we do when we're going to solve a quadratic like this is factor it. Notice what makes this different from the work we did yesterday, where we solved those algebraically. In this case, I have both an x squared and an x. And the ones we did yesterday, it was always either x squared equals some number, or x plus or minus some number squared equals a number, at least by the time we boiled it all down. The fact that this has the x squared and the x in it means we have to do something a little bit different. So we factor it. And now that I've factored it, I can easily set it equal to 0. Because let's say I made this whole parenthesis here equal 0. I don't know what I plugged in for x yet, but I made that parenthesis equal 0. 0 times anything minus 3 doesn't matter what that x value is, right? Because anything minus 3 gives us some number. What's 0 times anything? 0. And so if I make just one of those parentheses equal 0, I can make the whole thing equal 0 because they're multiplying. And 0 times anything is 0. So basically what I'm doing here is I am individually solving the x minus 12 set equal to 0 and the x minus 3 set equal to 0. I'm just solving each of those. Now you can probably do these pretty quick in your head, right? Because what minus 12 equals 0? 12, right? Now, if you're not sure why, you can actually break out the equation like this and actually write it out. So we add 12 to both sides, and then we get x equals a positive 12. Same kind of thing with that second one, x minus 3 equals 0. Well, what minus 3 equals 0? 3. If you don't see it right away, write out the equation, add 3 to both sides, x equals 3. And by doing that, we then have both of our solutions. Just like the work we did yesterday, when we're solving a quadratic, we end up with 2 answers. So that means we finished that first one out. Now for the second one, again, we started by factoring it. Notice it's the exact same thing, so all you had to do is just add the 0 onto the expression you had before, and then you're caught up with the same work. But now we need to actually solve this one. The question, though, is, what's the 5 do? That's normally the question that comes up. So let's take a look at what that would do. Well, first of all, let's say I make this parenthesis equal 0. All right? So I'm just wanting to make that equal 0. Everything else, I'm just going to leave it as it was. So I'm just saying, what if I just make that one thing equal 0? Well, what's 5 times 0? 0. And so then this part here will still give me 0. And then 0 times the x plus 7, of course, will equal 0. Because 0 times anything, x or not, is always going to be 0. And so the 5, you'll notice, didn't change it. Now, what minus 2 does equal 0? In other words, what can I plug in here? Well, if you're not sure, remember you can actually set it up as an equation, x minus 2 equals 0, and solve it. Notice I'd add 2 to both sides, x would equal 2 there. And then for the other parenthesis, you do the same thing. You say, what plus 7 equals 0? And there, you subtract the 7 from both sides, hence we get negative 7 as our other answer. You notice that for both of those, the 5 that was out front did not change it. The reason is because that 5 that's out front of this expression, it has no x in it. So it's not affected by what x would be. And so 5 times 0 is still going to be 0. All right, I'd like you to use the techniques that we just took a look at on solving these to solve these 2 equations. And again, notice both of them involve both x squared and x. Whenever you see that, that tells you factor it first. So on that first one, the first thing I hope you're doing is you're looking to see, is there something I can divide every term by? So I see the 2 out in front of the x squared. Obviously, the only thing that's going to be able to come out of that is a 2. So can I divide the 16 and the 30 also by 2? Yes. So let's start by doing so. Start by factoring that 2 out of every single term. Once you've done that, then you can actually concern yourself with factoring the quadratic that remains. So now we're looking at x squared plus 8x plus 15. All right, well, thankfully that's one of the easier ones. All I'm doing is saying what two numbers add to 8 and multiply to 15. Hopefully that's a quick one for you, because whenever we think of 15 and what multiplies to it, we tend to think of 3 and 5, and that one works. And so then this is our final factored form, but it is not our answer. Remember that what we're asked to do here is to actually solve it. We aren't just asked to factor, we're asked to solve, and solving just requires that we do the factoring first. So now for solving, I look to say, what can I plug in for x that makes it equal 0? Well, the 2, there is no x there, so there's nothing we can do to make that equal 0. All right, what plus 3 equals 0? What plus 5 equals 0? Should come up with -3 and -5. And again, if you don't just look at it and know that, you can always write out x plus 3 equals 0, solve it. Subtract 3 from both sides, hence that's why it's x equals -3. Same thing for doing with the x plus 5. All right, now we take a look at the second one, the one next to it. Again, it starts out with a 2x squared, and so I got to look and see, can I factor that 2 out of every single term? So, can I pull it out of all 3 terms? No. That means that I cannot start by just factoring a 2 out of every term here. Instead, I'm going to have to factor it the long way, that is with the grouping method. So, I start by figuring out what AC equals. So A times C, in this case that's 2 times -10. So that's going to be -20. So I'm saying what two numbers add to -1 and multiply to -20. Well, thankfully those are still pretty easy numbers to work with. So I'll have my 2x squared, that part isn't going to change at all. And then I'm going to split up that -1 into a -5x and a positive 4x, because -5, positive 4, those are my numbers that add to -1, multiply to -20. -10 equals 0. And then, of course, factor from there, so I pull an x out of the first 2 terms, and I pull a 2 out of the last 2 terms. When all is said and done, this is what we're looking at as our factored form, x plus 2 times 2x minus 5. Still equals 0. That equals 0 is just still hanging out down the right-hand side. All right, now hopefully by now you have started seeing some pattern, right? In terms of, okay, well, if this is x plus 2, what is x going to equal? That's going to be -2. Because basically it's just always been the opposite, right? So like plus 3 meant that it was then a -3. Plus 5 here meant that then it was a -5 here. And so it's always been the opposite there. But in this case, we see something that we got to look out for. Because the other answer here is not 5. And so, yes, that can work, but only some of the time. Now, there is a pattern you can use with this one, too. I'll let you look for it on your own. I won't tell you today. But if you don't see what the answer is right off the top of your head, again, write out the equation, 2x minus 5. We want that parenthesis equals 0. So solve that. And so, if you're solving that, you would then go ahead and add 5 to both sides. So we have 2x equals 5. And then we would divide both sides by 2. And so you notice x equals 5 divided by 2, or you could write it as 2.5, or you could write it as 2.5. Any of those ways of writing your answer are fine. I'm not picky about which one it is. Why did I write it as a decimal then? Because it was easier to type. That's it. So definitely the fractions are good if you feel like going with the fractions. Either 5 halves or 2.5 is acceptable there. It doesn't have to be one way or the other.